Hello everyone, so we had done finding the square root by prime factorization method in our previous video, and now we are going to learn finding the square root by long division method. So prime factorization method would work only on the perfect squares. This long division method can be used for perfect squares and non-perfect squares. Let's start doing some examples. So just see, there are few concepts which you need to know. So let's start with example 1. So let's take a 3-digit number first. 784. So I have to find out the square root of 784. 784 and division method. Here we have to see the number of digits and we have to start pairing from the right hand side. So pairing of numbers. So pairing 8 and 4 becomes one pair from the right hand side. Now we are left with 7 here, that is single digit. So now we have to look for a number such that if we multiply that number with itself, it should be less than or equal to the 7 here. 3 times 3 will become 9, so I can start with 2 here. So I get 2. Same like division, so 2 times 2 is 4 and we'll follow the division by subtracting. So I get here 3. And here I'll take down both these two digits. So we have to take down the numbers in pairs. So I get 384. Now on the divisor side, I have to add the same number here. So this becomes 4. And I leave the space for the ones or the units digit. Now I have to put my ones digit such that if I multiply 40 with that units digit, so that it becomes less than or equal to 384. 8, 9. 9 4 times will be 36, but it will be more than 384 if I multiply 49 by 9. So let me take 48 and 8 here. So 8 times 64, 8 4 times 32 and 38. Okay, it's a perfect square. So I can see that square root of 784 is equal to 28. So example 2. So let me take 5329. Let's go ahead with that. So 5329 I have to find the square root for. So I am going to make pairs from the right hand side. So here I have pair of 2 and 2 digits. Now I'll start. I have to look for a number such that if I multiply with itself, it should be less than or equal to 53. So 7 times 7 into 7 will give me 49. Now subtraction as we do in division, 4, and I'll take down these two digits. So I have 29. Now on the divisor side, as you know, we have to add the same digit here. So this becomes 14 and I have to find out the units digit here, such that if I multiply the whole number with that digit, I should get less than or equal to 429. Let me see, I think it will just go by 3. So 3 here and 3 here. So 3, 3, 9 and 3, 4 times 12 and 4. So I get 73. So I can see that square root of 5329 is equal to 73. Let me take one example which is 5 digits. So example third, let's take 10609. Let's go ahead and write down this here. Start dividing. So we'll first make pairs from the right hand side. So these two, and one is left alone. So now I'll start dividing. So first one time 1 minus here, this on divisor side it becomes plus 1, so I'll get 2 here, and I'll take down 2 digits, so I get 0 and 6. So now it will be a 2-digit number, but it can't be less than 6. So as we do in division, I'm going to put 0 and 0 here, so I'll get 2 zeros. Then subtraction, so I'll get 6, and I'll take down these 2 digits too, so I get 609. Here I'll add 0, same digit I have to add in each step, which I have added in the units place, so 200. And here I have to put my ones digit such that if I multiply with that digit, I should get less than or equal to 609. So I can see I can multiply with 3. So 3 times 9, 0 and 6. So I can see that square root of 10609 is equal to 103. Now let me take one more example for 5 digits. So example 46649. So let me write down 66049. Let's make pairs. So these two, and this 1 6. Now I will start dividing. So now 2 times 4, subtracting, I get 2 here. Then on the divisor side I have 2 plus 2, so 4 here, and I'll take down the 6 and 0 in pairs, so 260. Here I have to add units digit such that if I multiply this whole number by that units digit number, should be less than or equal to 260. So I think I can go by 5 here. 5, 25 and 2 carry 5, 4 times 20, 2. So on subtracting, I get 5 here and 3 here. Then I can take down these 2 digits here. So I get 4, I get 9. Now on the divisor side I have to add 5, the new units digit which I added in the last step, so I have 50 here. Now I have to add a number in the units digit such that if I multiply this whole number by that units digit number, will be equal to or less than 3549. So I can see clearly it would be 7. So 7, 49 and 35. Subtracting, I'll get 0. So I can say that square root of 66049 is equal to 257. So we have done a few examples which were perfect squares and we could find out by division method. So important point here is to make pairs from the right hand side and then adding the units digit number for each next divisor. Now let's take some decimal points, because little bit rules are changing after the decimal point. So now let's take example 5. So let's take 1.96. So in decimal points, what is the change in the rule is for the pairing up. Before the decimal point, we have to make pairs from the right hand side, but we have only one digit here, so that's fine. And after the decimal point, we have to make pairs from the left hand side, so these are 2 here. Okay, let's go ahead. So we will follow the same thing now. So 1 time 1, I get 1 here, and I'll put the decimal because I am going to take down the digits after the decimal point. Same rule on for the divisor side. I am going to add 1. I have 2 here. So here I have to find out the units digits such that if I multiply with the number, then I should get less than or equal to 96. It goes by 4. 16 and 9. Square root of 1.96 is equal to 1.4. Let's take another example. Example 6. So let's take 42.25. So I have to find out the square root of 42.25. Let's make pairs. So before the decimal point from the right hand side, after the decimal point from left hand side. Then we have to start dividing. So I have to think of a number which multiplied by itself should be less than or equal to 42 now. So 6 times 6 will give me 36. Subtracting, I get 6 here. I'll put decimal point because I am taking down the digits after the decimal point. So 2, 5. Here on the divisor side, I get 6 plus 6, so I get 12 here. Now I have to think for a number on the units place such that if I multiply with the same number, I should get less than or equal to 625. So clearly I can see 5 here. So 5, 5, 25, 10 and 2, 12, 1 carry and 625. Subtracting, that's fine. So I can say square root of 42.25 is equal to 6.5. Let's do some more examples. Example 7. I'm just trying to cover different examples so that this process becomes easier for you all. So let's take 6.4009. Now let's start finding it out. So we have 6.4009. So let's start pairing up. Before the decimal point from right hand side, after the decimal point from left hand side. So now I have to start dividing. Now let's see, what do I get? 2 times 4, minus sign, 2 here, and I am going to take down the digits after the decimal. So decimal point here and 4, 0. For the divisor thing, I am going to add 2, so I get 4 here. Now I have to think for a units digit number such that if I multiply with the number, I should get less than or equal to 240. So 5 times 5 here, 25, 22. Subtracting, I get 1, 5, and I am going to take these 2 digits too. So 0 and 9. On the divisor side, I am going to add 5. So this becomes 50, and I have to look for the units place digit. So it's 3. So I can write down 3 here. 3, 3, 9, 0 and 15. Subtracting, I get 0. So I can write down square root of 6.4009 is equal to 2.53. Let's take more examples. So example 8. So I can take the digits 0.4225. Now let's see 0.4225. Let's make the pairs from the left hand side. So these two. I'll start with the decimal point. So 0. I have to consider 42 for the starting point. So 6 times 36. I get 6 and I'll take down these two digits. So 25. On the divisor side I'm going to add 6, so I get 1, 2. Now I have to think for the units digit. So 5 times and 6, 25. We had done 42.25 also in our previous example. So we were getting 6.5 because of the decimal point, and here we are getting this. So I can write down square root of 0.4225 is equal to 0.65. Okay, so these few examples which we have done, it's a terminating decimal point. Let's do some more examples. So let's do example 9. So let's take non-perfect square. So 5, 4, 7, 8. So let's start doing it. 5, 4, 7, 8. First step to make the pairs, so this way. Now we have to think of a number which when multiplied by itself should give me less than 54 or equal to 54. So 7 times 7, 49. Subtracting, I get 5, and then I have to take down these two numbers, 7, 8. On the divisor side, I have to add 7, so it becomes 14. And now I have to add the units number such that multiplied by that number should give me less than or equal to 578. So it will go by 4. We have 4 here. So 16 and 7, then 5. Subtracting, we have 2 here. And on the divisor side, I have to add plus 4. So 148. Now I'll put decimal and a pair of zeros. So now if I get the units digit, any digit, it will be greater than 200 because it's a 4-digit number. So let me do with 0, 0 here. So 0, 0, 0. Then I have to subtract this side. I have 200 and here 1480. So now I have to add the units digit here and here 2 more zeros because I have already put the decimal. So pair of zeros here. Now it will go by 1. So 1 time 14801. Let's subtract. So 9, 9, 1 and 5. So next step, again I can add 2 zeros here and plus 1. So this would be 14802. Now I have to add one more digit here. So let's have it as, I think 3 would be fine for that. So let's take 3 here and 3 here. So with 3 I'll get 9. 6, 0, 4, 4 and 4. Now subtracting here, I'll get 1, 3, 8, 5, 7. And on the divisor side again I have to add 3. So I'll get 1480 to 6. And I have to add one units digit number and here a pair of zeros. So I think I can go ahead with 5 here. So 5, 2 carry, 32, 3, 10 and 3, 1 and 5, 8 times 40, 4, 24, 2 and 7. So subtracting here, I get 5, 9 minus 2 is 7 and 7, then I have 1 here and this would be 8 and this would be 1. And I can go ahead, keep on going like that. So next time I'll have to add digit 5 and this book comes 1480270. Then again I have to add the units digit and 2 zeros here and then I can keep on going. So I think next time it will be one time. So that would be 1480270. It seems that it is a non-terminating decimal point, so it will keep on going, but we can find out up to these. Now I can say that square root of 5478 is equal to 74.01351 and it will keep on going. And usually we can find out up to 2 decimal points or 3 decimal points, or find out up to 3 decimal points and approximate to 2 decimal points. So if I approximate to 74.014. Now let's take another example, example 10. Let's take the number 2. This is used many times. So let's find out the square root of 2. Maybe we can find out up to 4 decimal places. So let's take 2, pairing up, no pair, so it has only one number. So we'll go ahead with 1 time 1. Then this side we have 1 decimal point, 2 zeros. For divisor I'll have 2 here. Then I can go for 4 times 1696 minus 4, 2 pair of zeros plus 4 here, this becomes 28. And I have to think units digit number. I think 1 is fine, so 1, and we have 281. Subtracting, I get 9, 1 and 1. Now this side it becomes plus 1, so we have 282, 2 zeros here, and I have to find the units digit. So units digit I can go with 4. That should work. So 4 here, 4, 4, 16, 1 carry, 4, 2, 8 and 1, 9, then 32, 3, 11. Subtracting, I get 4 here, 0 and 6. Then I can add 4 here for the next step and 2 zeros here. So 2, 8, 2, 8, and I'll have to add one more units digit and the thing will keep on going like that. So I can write down root 2 is equal to 1.414. Now let's take example 11. Let me take 0.8. So let's start doing 0.8. in this case, I have to start making pairs from the left hand side. And after the decimal point, I can add any number of zeros, right? So I can start making pairs like that and so on. So now let's find out. So this I will start with 0 here, 0 point, and 80 means I can go 9 times will be more. So 8 times 64 minus I get 6 and 1, and I'll take down 2 zeros here. This side I'll add 8 and this becomes 16. Now 9 times I can go ahead with that. So 9, I have 8 and 2, 5 and 1, 15. So this I get 7 and 9. Here this side I am going to add plus 9. So I have 1, 7, 8. I can take down 2 more zeros, keep on adding this number of zeros. Now I can go 4 times. 4 times. Okay, 16, 1, 32, 33, 3 carry, 28 and 3, 31, 3 and 7. So the subtracting I get 4, 6 and 7. And this side I'll have plus 4. So 1, 7, 8, 8. And again I have to keep on adding the 2 zeros, and I can keep on going, adding, finding out the ones digit number next one. It may be around again 4 only, so then we can go ahead like that and keep on doing. So that's fine. And we get square root of 0.8 is equal to 0.894, and we have done all different variations of finding the square root by division method. We have done for 3 digits, 4 digits, 5 digits, decimal points and non-perfect squares. So I think it should be clear, and let me know in the description box if you have any other doubt. I can go for more examples. Thank you for watching, and see you in the next video. So stay tuned.